Hello everybody. In this video we will discuss which one of these two is more acidic. So the way we will decide is the same way we decided in the previous video, where the first thing we have to do is find out their conjugate base, what happens after the acidic proton is gone. So we have cyclohexanol on the left side. So this is our acidic proton right here, and in phenol there is also acidic proton. So let's look at the structure that's going to come out once the acidic proton is gone. So you can create a negative charge on oxygens right there. You can also create the negative charge over here. I'm showing all the double bonds. These double bonds are delocalized, but I'm showing them for a reason. I'll show you in a second. So now we have two conjugate base. Now, whichever the conjugate base is more stable, if this one is more stable, that means the corresponding acid is more likely to give away its proton. So which means the corresponding acid will be stable. Now, how can we find out which one is going to be more stable? Well, the way we can do that is look at how the electron, the negative charge on oxygen, is being dispersed across the other portion of the molecule. So in the previous video, we discussed inductive effect. Okay, so if you haven't watched that, make sure you watch it. In this video, we will talk about something called resonance effect. So how resonance effect helps us distributing this negative charge throughout the molecule. So here, the negative charge on oxygen cannot be distributed through resonance effect. So this portions, so there is no resonance effect on the molecule on the left side. Now you must be wondering why. This will make sense in a second if we look at the structure here, how we can delocalize the electron, the negative charge on oxygen across the molecules. So we can start drawing the resonance contributing structure. So what will happen is this negative charge on oxygen can move here, and we're going to maintain the octet of carbon all the time, right? So in order to maintain the octet electron, these pi electron, we might be able to move this pi electron to this carbon atom. So we can create a resonance contributing structure that would look something like this. So where you have the double bond is with oxygen. However, the negative charge now is on this carbon atom, and everything else stays as it is. Okay, so everything else stays as it is. So we can draw more contributing structure. So you can see here the negative charge here from oxygen. Now we disperse that across to this carbon atom. So we can keep doing this. We can move the negative charge back again to the next bond and move this pi electron to this carbon atom. And then we're going to have a scenario where okay, so now we can have the double bond here. Negative charge is here. Nothing happens with here. Okay, let's make this structure a little bit cleaner. Okay, so that's the next contributing structures. And then we can again do another one of these. Move this electron back to this bond and this pi electron back to this carbon atom. So the basic idea is more structure you can draw, so more resonance contributing structures you can draw, more stable something would be. So now you have double bond here, and the negative charge is here. And now we are getting back to the full circle where we can bring back the negative charge back here and bring the negative charge back to oxygen. So you can see if we do this, we'll make the structure where we started. So this is something called resonance effect, where these are all resonance contributing structures. And more structures you can draw, the more stable that negative charge is. So this is what gives the stability of our conjugate base. So now this is why the one structure right here. So this is our conjugate base, right? So this conjugate base is more stable because of the resonance effect, because we could draw all this resonance contributing structure, and as a result, so what have we told before? If a conjugate base is more stable, then the corresponding conjugate acid, which is in this case the structure on the top, is gonna be, so this structure on the top is gonna be more acidic. All right. Okay, so I'm gonna give you a problem. Make sure you pause the video and tell which one would be more acidic. Answer would be on the comment. So let's say you have something like this. Versus so which one of this structure is going to be more acidic? Remember, the acidic proton is this one. This is the acidic proton we are discussing here. So your question is, which one of these would be more acidic? So the answer would be on your comments. All right, so let's stop the video here.